Right, okay, this is question 2, part C of the June 2014 FP1 paper. Okay, we've already done parts A and B. Same function, and it says using x0 equals 1.1 as a first approximation to alpha, apply the Newton-Raphson procedure once to f of x to find a second approximation to alpha, giving your answer to 3 decimal places. So we've only been told to do it once, we've been told to give our answer to 3 decimal places. Okay, and also to use x equals 1.1. Actually, they're being fairly kind with this question, because we've already used 1.1 to calculate some of the things we're going to need in a Newton-Raphson algorithm procedure, same thing, in parts A. So, you know, we should cut down the amount of calculation we have to do. So here's our Newton-Raphson procedure, Newton-Raphson algorithm. Basically says that it's an iterative formula, algorithm procedure. Basically means that, you know, the next term is given by the old term minus f of the old term over f dash of the old term, okay? And, you know, you should get closer and closer to where you want to be. In this case, it's alpha, which, of course, if you remember from Pi 8, is our root, the point where the graph crosses the x-axis. Okay, now in part B, we worked out, now if you look at this formula, we're going to need f dash, going to need f of x. Well, we know what f of x is, we know what xn is, we know what f dash is, because we've worked it out in part B. F dash is this thing. Okay, and using x0 equals 1.1. So, f of x0 is going to equal f of 1.1. The key with this question is just really to lay it out. Lay out exactly what you need and then stick it in. So then the examiner can say, okay, I can see that he's worked everything out correctly. I can see he's got all the parts. Also, it's clearer in your head, it's logical. If you get into this habit of writing it out nice and clearly, nice and logically, then it should be a piece of cake to you. Okay, and we've already worked this out to be negative 1.64. Now I must make a small confession here. In part A, you saw me work this out and I got it to negative 1.63. I didn't round the 3 up to a 4, so I do apologise for that. I wouldn't have lost a mark if I'd done that, because my other f of 1.5 was correct. I did say that if it was just slightly out, I would have still got the mark, but even so, I will make the confession now and I will apologise for that now. Okay, now I'm going to work out f dash of x0, so in other words f dash of 1.1, and I'm going to work that out by simply sticking it into this formula here. So that's going to be equal to 3 of 1.1 all squared plus 15 over 4 times 1.1 all to the power of 5 over 2 plus 2. And when you calculate that in the calculator, okay, remember, tip is use brackets, then that comes out as 8.585. Okay, now we've got all the bits that we need to work out what x1 is equal to. Remember, x1, we're approximating alpha. Okay, so alpha is equal to x1 in this case. And that is equal to x0 minus f of x0 over f dash of x0. Okay, which is going to be equal to, so x0 is 1.1. F of x0 we worked out as negative 1.64, and f dash of x0 is 8.585. Okay, stick that into a calculator. Be careful of your double negative here, that's going to obviously become a positive if you get rid of that negative there. And that should come out as 1.291, 3 decimal places. Where are your marks? There's going to be 1 mark for calculating f dash, because we haven't got that yet, so there's going to be 1 mark there. There's going to be 1 mark of the correct application of Newton-Raphson, because of course they haven't given it to us, so it's showing that you do actually know what Newton-Raphson is. And the last mark is obviously your answer. Remember, 3 decimal places, that's what the question is asked. Usually, you know, you give it 3 significant figures, it's 3 decimal places. You need the 291 on the end in order to get the full 3 marks.